Welcome, y'all. Back to some Algebra 3. So, how are we going to do this semester? Well, this is what we do. We are going to assign you, of course, we always provide videos for you to teach you the lesson, and I will be assigning you work with answers already on those. Your job will be to give me the work, show me the work, and turn it in via Google Classroom. So, this first section, we're splitting it into two parts. So we're going to start with this first part, which is adding, subtracting, and multiplying complex numbers. Now, if you don't get this meme, let's go over it. So first off, let's talk about the number I. So I is what we call an imaginary number. It's imaginary because you technically cannot square root a negative number. So negative numbers do exist, and square rooting of numbers exists. But them together, that's not possible. Kind of like fractions exist and zero exists, but you cannot divide by a zero. That kind of ruins it, makes it almost impossible. So that's what how I is used here. Is kind of to tell you this represents this, but it's not a thing. So for example, if this was, we take this as I, but let's take a number something like radical -4. Radical -4. So what you do is you split it up to be radical -1 times radical 4. Radical -1 then becomes our I. So it'd be I radical 4. Because then you can actually square root that. Square root the 4, you get 2 with the I right there. So this reduces to be this right here. That's where we use that, because then we still can do some math with it. But let's look at adding and subtracting these. So just like anything else, think of like terms. You have to combine like terms. So for example, we got our constant whole numbers, and there are complex numbers right there. Now the whole thing as one is a complex number. Two different things, a constant real number and a real and imaginary number. So put it together, that makes a complex system. But we're combining like terms. So here we're saying, hey, 8 plus 6i plus 3 plus 2i. So in the parentheses, we cannot add anything in either one. So kind of drop the parentheses. So we say 8 plus 3. Oh, 8 plus 3 is 11. Yep, you're right. Good job. And then 6i plus 2i, you add them just like you would any number. If it was x's, you still 6x and 2x. So 6i plus 2i gives us 8i. That's it. That is adding complex numbers. Slowly ease you into this. All right, so let's look at subtracting these. So just like adding them, we look for like terms and we look inside the parentheses first. Can we add those? No. Can we subtract those? No, they're not like. So then we go across. So we're saying, hey, 4 minus 6. So 4 minus 6, this is a -2. And then 5i minus a -3i. Well, that's minus a -3i. So it becomes a plus 3i. So 5i plus 3i gives us 8i. And that's it. That is subtracting these right here. Subtracting these. Now let's look at the multiplication side of this. Not as bad. So multiplication of complex numbers is very simple. So we still do numbers like normal. So 8 times 8. So let's look at something more familiar. 8x times 8x. If you're multiplying those, you get 64x squared, right? Well, these work the same way. 8 times -8 gives us -64. And then I times I gives us an I squared. But unlike an x squared, an I squared does have a value. So I squared is like saying you're taking radical -1 and you're squaring it. And like we talked before, anytime you have a square root being squared, they cancel each other out, leaving you just what's inside, a -1. So we have -64 times a -1. That I squared becomes a -1. You multiply them together, you get positive 64. Now let's look at something a little bit more complex with multiplying complex numbers right here. So just like you would any other set of binomials, you distribute the information. So 1 times 1, 1 times 3i, 2i times 1, 2i times 3i. So 1 times 1, 1 squared, or just 1. 1 times 3i gives us a positive 3i. 2i times 1 gives a positive 2i. and then 2i times 3i gives us a positive 6i squared. And like you would any other binomials, you add like terms. So we got 1, it's only 1 right now. And then 3i plus 2i gives us a positive 5i. Now let's look at the 6i squared. Remember, I squared becomes negative 1. So this becomes 6 times a negative 1. You multiply that, we get a negative 6. And then we can combine like terms one more time. 1 minus 6 is a negative 5 plus 5i. So even though the negative is in front, we always try to keep all the whole numbers, the constant numbers, the real numbers, quote unquote, in front of the imaginary, just like this. Now, let's look at this problem. So we're saying 3 minus 7i squared. So remember, that is saying you're going to do 3 minus 7i times another 3 minus 7i. And just like before, we distribute the work. So 3 times 3, 3 times negative 7i, negative 7i times 3, and negative 7i times negative 7i. So 3 times 3 gives us 9. 3 times negative 71, or 7i, sorry, is negative 21i. Negative 7i times 3 is also negative 21i. And negative 7i times negative 7i is positive 49i squared. Combine like terms, we got 9 minus 42i. And then remember, this becomes a negative 1. So you take negative 1 times 49, becomes a negative 49. And then we combine like terms one more time right here. So 9 minus 49 gives us negative 40 minus 42i. All right, y'all. And that's multiplication of complex numbers. Bye.